So we're talking about atoms and construction of atoms. Which electron is, on average, closer to the nucleus? An electron in a 2s orbital or an electron in a 3s orbital? Well, remember what those 2s and 3s mean. The 2 and the 3 are your energy levels, or your N value. So N equals 2 versus N equals 3. This is further from the nucleus, because you've got your nucleus in the center, then you've got your N equals 1 energy shell, your N equals 2 energy shell, your N equals 3 energy shell, N equals 4 energy shell, and so forth. So this is where all of your protons and neutrons reside. Then you've got your N equals 1, N equals 2, N equals 3, N equals 4, and that goes up to N equals infinity. So here, the electron in 2s is closer to the nucleus. What about here? What are the possible values of L for each value of N? So your quantum numbers. Remember what L does. L describes the shape of the orbital. N tells you your energy level. L is equal to 0 up until N minus 1. So any value from 0 up to N minus 1. And for ground state, remember L equal to 0 means an s orbital. L equal to 1 means a p orbital. L equal to 2 means a d orbital. And L equal to 3 means an f orbital. If I have an N value of 1, the only possibility for L is 0. The only electrons that can exist in the N equals 1 energy level are your s electrons. We only have 2 s electrons that reside in that L equals 1 energy, or N equals 1 energy level. If N equals 2, I could have an L value of 0 or an L value of 1. So again, what this means is that I have 1 s electrons. Here I have 2 s electrons and I have 2 p electrons. In total, I can have 2 electrons in every s orbital. I can have 6 electrons in every p, 10 electrons in every d, and 14 electrons in every f. If n equals 3, I have L values of 0, 1, and 2. I have 3 s orbitals, or a 3s orbital, 3 p orbitals, and 3 d orbitals. If n equals 4, my L value can be equal to 0, 1, 2, or 3. I have a 4s orbital. I have 4p orbitals. I have 4d orbitals. And I have 4f orbitals. What are the possible values of m sub L for each L value? So remember, m sub L goes from negative L through 0 to positive L. So if my L value is equal to 0, my m sub L can only be 0. That happens and that's telling me, again, this is when L is equal to 0, I have an s orbital, and so there's only one shape for that orbital. When L is equal to 1, my m sub L is equal to negative 1, 0, or plus 1. In this case, I have 3 degenerate, meaning equal in energy, orbitals. These are my p's, my p orbitals. When L is equal to 2, my m sub L values are negative 2, negative 1, 0, plus 1, plus 2. I have 5 degenerate, meaning equal in energy orbitals, and these are my Ds. And when L equals 3, my M sub L values range -3, -2, -1, 0, +1, +2, +3. And I have 7 degenerate, meaning equal in energy orbitals. Sketch the 1s and 2p orbitals. How do they differ and how many electrons do each orbital hold? Now, it doesn't specify which 2p orbitals, so we'll just draw all of them. But your s orbitals are just a sphere, okay? Your 1s orbital just looks like that, and it holds 2 electrons. Your p orbitals, let's count this, x, y, z, x, y, z, x, y, and z. So you have your px, which they look like a dumbbell shape. You have your py, and you have your pz, which we're going to pretend that that line is actually on the line. Okay, so your px is centered on the x-axis, py is centered on the y-axis, and pz is centered on the z-axis. So your 2px, 2py, and 2pz look like. Each one holds 2 electrons. The node in the center, this is called your node right here, is where your electrons are not allowed to reside. There's no electron density there. They can exist in the lobes. And your lobes, one would be positively charged, one would be negative. They just have opposite sign to each other. So we can differentiate by shading in one side or calling one positive, one negative. But overall, overall the 1s holds 2 electrons, and your 3 2p orbitals hold 2 electrons each, for a total of 6 electrons being held by the p's. Next up, what is the maximum number of electrons in an atom that can have the following quantum numbers? N equals 3, M sub L equals 1. Okay. If N equals 3, that's the third energy level. Which means I can have a 2s, a 2p, sorry, 3, a 3s, a 3p, or a 3d. Now, 3s cannot have a M sub L of -1 because -1 is describing the shape of it. S's only have M sub L values of 0. This cannot happen. But 3p could be -1, 0, or +1. 3d can be -2, -1, 0, +1, +2. So, maximum number of electrons in an atom that can have the following quantum numbers is just 2 electrons. Because each one of these, again, remember parallel before paired, but if it was full, I could have a 3p orbital with those quantum numbers or a 3d with those quantum numbers. But the M sub L itself, the M sub L value of a -1 represents one orbital, and one orbital can only contain 2 electrons. What is the maximum number of electrons in a ground state atom that can have the following quantum numbers? Okay, let's talk through these. N of 3, L of 0. N of 3 means energy level, third energy level. But L of 0 tells me the type of orbital I have. That tells me I have an s orbital. M sub L will be equal to 0 here, and s orbitals can only hold 2 electrons. It only has one M sub L value, therefore 2 electrons there. It can only hold 2 electrons. And N equals 4 and an L equals 3. L equals 3, so this means 4th energy level. L equals 3 means a D, well, actually, yeah, N equals 3 means sorry. L equals 3 means an f orbital, which means I have -3, -3, -2, -1, 0, +1, +2, and +3. These are all of the orbitals I can have that can have these two quantum numbers. They can have um, N equals 4, L equals 3, can have all of this. F orbitals have 7. Each one of these can hold 2 electrons. So 1, 2, 3, 4, 5, 6, 7, parallel before paired, 8, 9, 10, 11, 12, 13, and 14. Whereas this can only hold 2 electrons, this quantum number can actually have up to 14 electrons. N equals 3 and M sub s equals -1/2. N equals 3 is 3rd energy level. M sub s equal to -1/2 is the spin on the electron. So that means I can have a 3s, a 3p, or a 3d. It didn't specify which, and which electrons can be spin down. Well, s only has one orbital shape, so that's only going to have one electron spin down. 3p has 3 orbitals, so it can have 3 electrons spin down, and 3d has 5 orbitals, so it can have 5 electrons spin down, so 5, 8, 9 electrons can follow this scheme. And N equals 3, M sub L equals 1. It's your 3rd energy level again. M sub L is telling you the orientation of that orbital. So 3rd energy level could be 3s, 3p, or 3d, but 3s cannot have an M sub L value of 1. 3p has one orbital that has a M sub L value of 1, holding 2 electrons, and 3d also has one orbital of M sub L value of equal to +1, holding 2 electrons. So overall, 4 electrons here.